Section 13.7 is about inverse trigonometric functions. Inverse functions are something that we've actually used a few times in the past couple of sections. And Section 7 has more than what I'm about to show you, but I'm just going to give you the basics of the inverse functions that we need to know, and then we're going to move on from there. This concept summary shows us that there is such a thing as an inverse sine, an inverse cosine, an inverse tangent. Now the way you write the inverse is by putting the -1 exponent on the sine, and we say that that's inverse sine. It also has another name. It's called the arc sine. You can use those terms interchangeably. There's also an arc cosine and an arc tangent that go along with cosine and tangent. Down in this table you'll find three values that all are equal. Y equals sine of x is the same as x equals inverse sine of y, and that's the same as x equals arc sine of y. And the same goes for cosine and tangent. In this problem we want to find x so that the sine of some angle is square root of 3 over 2. Now to do this with a calculator, you're going to have to isolate the x, and to do that you're going to have to take the arc sine, or the inverse sine of both sides, because inverse sine and sine are opposites and they cancel each other out. So we get the inverse sine of square root of 3 over 2, which you can plug into your calculator. If you do that, you're going to get x equals 60 degrees. Here's some more calculator problems. You have to find each value of these. The arc sine of square root of 3 over 2 is the same as the inverse sine of square root of 3 over 2, which is what we just did on the last screen, which is what we just did on the last slide, except that was in degrees. This one says to write the angle in radians. So you're going to have to take your calculator and change it into radian mode. If you do that, you'll find the inverse sine of square root of 3 over 2 is 1.05. Now that's in radians. Same thing over here. The inverse cosine of 6 over 7 and the tangent of that. Make sure you type it in your calculator properly and that it's in radian mode. And you're going to get about 6.0. The last problem I'm going to do is one that we've done in the past. We want to find the measure of angle theta. We know the adjacent leg and the hypotenuse. Adjacent and hypotenuse is cosine, so if I say the cosine of theta equals adjacent, which is 90, over hypotenuse, we can get rid of cosine, I should say, by taking the inverse cosine or the arc cosine. And then this is a calculator problem. Now making sure your calculator is again in degree mode so we can get a degree answer, we find out that angle theta is about 46.2 degrees.